Hello students, in this video we'll discuss the equivalent arrow theorem and define vectors. Recall that two arrows AB and CD, so they're just directed line segments, are called equivalent if they have the same magnitude and direction cosines. Or direction angles. Now what that means is it means that, let's recall what the definition was. So recall, for example, one of them would be the cosine of alpha was xb minus xa over the length of AB. That would be the cosine angle for the arrow AB. This, if AB and CD are equivalent, has to be equal to the length of CD, and on top I'll have a xd minus xc. Now, since they have the same magnitude, since they're equivalent, these expressions are the same, and therefore the numerators must be the same. So what we know for equivalent arrows is that xb minus xa has to be equal to xd minus xc. So the difference in the x terminal point and the y terminal point has to be the same for both of those arrows. And that gives us the way to check if arrows are equivalent. So it's called the equivalent arrow theorem. So it is the equivalent arrow theorem. The equivalent arrow theorem states that if we're given two arrows, A, B, and CD, are equivalent, these arrows are equivalent, if and only if the difference of xb minus xa is equal to xd minus xc, yb minus ya is equal to yd minus yc, and zb minus za is equal to zd minus zc. So the differences in x must be the same, the difference in y must be the same, and the difference in z must be the same for arrows to be equivalent. This provides us a way of checking that arrows are equivalent very easily. Now we're in a position to define what vectors are. So for example, we should note if we have the arrow, let's look at the arrow 0, 0, 0, that's my first point, my arrow, to the point 0, 0, 0 to the point x, y, z. Let's look at this arrow over here. Then what I can do is I can say this arrow is equivalent to any shift of it. So what I'll do is I'll look at this arrow over here. I'll look at h, h, h to x plus h, y plus h, z plus h. Or I can shift all the individual entries. I could do something like this. It's also equivalent to L, H, K to x plus L, y plus h, and z plus k is equivalent to this. And let's check. Over here, the difference in the x coordinates is going to be x. The difference in the y coordinates is going to be y, and the difference in the z coordinates is going to be z. Over here, the difference in the x coordinates is going to be x. Over here, it's going to be y, and over here, it's going to be z. So by the equivalent arrow theorem, if you translate the x, the y, and the z on both points in the arrow, you'll get an equivalent arrow to the original. Now, with this notion of equivalent arrows, we're able to define what vectors are. So definition, a vector is a collection or equivalence class of equivalent arrows. So if I'm given an arrow will generate a vector v, and the vector v contains information about every arrow that's equivalent to AB. So any translation of AB is contained in the information of the vector. So a vector is an infinite collection of arrows that are all equivalent to each other. We'll see how that notion of equivalent arrow in defining vectors can help us define algebraic operations on vectors. Thank you very much.